As you all know, IoT is known as Internet of Things. Okay, from the expansion itself, you can able to understand by using the service of internet, you are going to transmit or you are going to communicate with other hardwares. Though, so here the hardwares are considered as things. Okay, so. With the help of internet, the hardwares which we are using for or within a network can transfer the data from one device to another device. So this can be called as IoT. Majorly when we start to work with this IoT, we need to know most of the details about electronic devices. This IoT devices was constructed with the help of embedded systems. As we discussed in the previous classes, like by using transistor or with the help of gate, you can able to create a circuit. And if you could add multiple circuit together, and if you could make that as a IC, that is in a hardware format, we can say that as integrated circuits, and which you can use for data communication or device controls. Okay, in the previous class, not today's class, but from the previous class, we can understand how we can able to build a transistor, and through which how we can able to create a gate, and the gates can be used for what. That's what we discussed in the last session. Okay, with the help of those knowledge, we can uh, understand the concepts of embedded systems. So the embedded systems is known as the combination of hardware and software. It has to use some programming language for the control of the hardware. The hardware can be built with the help of circuits. Okay, now if you are if you want to activate a hardware like a LED, then you need to go for the embedded systems applications. Okay, so most of the embedded system applications can be controlled or implemented with some of the available microcontroller and microprocessor. So the most commonly using microcontroller and microprocessors are PIC and ARM. PIC is the microcontroller which you can use to control the output devices, and microprocessor you can use to transfer the information to IO devices, through which you cannot able to control the input output devices. Means if you use microprocessor, you cannot able to control the input output devices actions and all. But if you use processor, you cannot able to control the IO devices actions and all. If you use microcontroller, you can able to control the input and output devices with the help of this microcontrollers. IC can be built with a set of circuits, and circuits can be built with the help of hardwares. Okay, so here consider you have a IC in with this architecture. Okay, so I can just explain you how a microcontroller or a microprocessor can be. Consider this as a architecture of microcontroller. In microcontroller, you may have n number of pins, but in PIC microcontroller, if you take, you'll be provided with 40 number of pins. Among the 40 pins, 8 pins alone can work as input or output pins. With the help of this, or by using the 8 pins, by using these 8 input output pins, you can able to connect input output devices within this pins. Okay, the other pins can be used for other purposes like timer and analog to digital conversion, and if you want to access any motor or any other electronic devices, you can use those things in other pins. Okay, but in this IO pins, you can able to connect IO devices. The IO devices, we know, the known IO devices are LED, LCD display, 7 segment, 14 segment, traffic light. This kind of IO devices you can use within this microcontroller. Okay, so now consider I am just going to connect a LED with this IO pin. So if I want to activate this LED, I need to write a program. So that's why I said embedded systems is a combination of hardware and software. So this LED is you can categorize this LED under hardware. And if you want to activate or deactivate, or if you want to control the actions of this LED, you need to give a program. So the program should be in the format of machine understandable format, that is zeros and ones. So to convert your program into zeros and ones, you need to use a specific software to convert your programming language into machine understandable code. For example, you can use C program, and by using some specific compiler, you can able to convert the C into embedded C program. Means you don't need to use a software to convert a C program to embedded C, but instead you can just change some methods or predefined words of C program to change or to convert the program into embedded C. So in embedded C, we have some specific terms which you need to use to take control of this IO devices. So with the help of that methods, pre-built methods, you can use one software to implement the code, and that software will take care of the code conversion from embedded C to machine understandable code. So the machine understandable code can be in the form of binary or hexadecimal, or it can be in the form of octal also. So that is not going to be a problem for us, but the software will take care of that. So if you write the program after the successful execution of the program, your software will convert the program into machine understandable code, and the format may be binary or octal or hexadecimal. So most of the time, most of the embedded softwares will convert the embedded C program into hex file format. So you can able to embed that hex file format or hex file into any IC to make it work. Okay, so this is how we'll start to work with this hardware. So this IC can, by using this IC, you can able to control the LED or any other IO devices and all. So this is what we are going to do now. Just give me a minute. Hello. Okay, so with the help of this microcontroller, you can able to control the devices. So here I'll just give you a simple example how this microcontroller can work, and how you can able to write embedded C program to activate this LED, or to deactivate this LED. Okay, so by considering this IO pins of this microcontroller, so this can take machine understandable code as input. So consider fan is running in your room. So we can state the status of fan with numbers, like 1. If the fan was switched on, you can say the state of that fan is in 1. If the fan is switched off, then you can state that fan status in 0. Okay, so if you could identify any input change from any specific devices, you can just denote that state change with numbers, like with 1 or with 0. So by activating all the hardwares, we can see the activation can be done with the number 1. Okay, so here also this pin will take one, and if the one passes through this line to this IO device, then it will get activated. If it carries zero within it, then this device will get deactivated. But this can be happen with the help of clock source. To create a clock pulse, you can use a specific hardware circuit called crystal oscillator. This crystal oscillator can produce the clock pulse to make the microcontroller work. So the strength of this crystal oscillator, which we are using in PIC, is 20 megahertz. So the unit of clock pulse, megahertz. So here this controller will work under this PIC microcontroller, especially work under the clock pulse strength of 20 megahertz. So if it finds the 20 megahertz clock pulse source can pass through this input output pins, so it will be ready to carry the input which you are going to give through program. So through program, if you are passing one to that IO pin, then it will carry one and it will pass the one to the connected IO device. Okay, so this is how this will work. And we can say a specific version of PIC microcontroller. You can take this as a specific version of this PIC microcontroller, 16F877A. So this is what the version we are going to see now. So when you use this microcontroller version, we can give expansion for this PIC as peripheral interface controller. So peripherals can be anything. You can take memory peripherals or input output peripherals or any other thing which you need to control. Okay, so those peripherals can be controlled by this integrated circuit device. So after this, the basic difference between microcontroller and microprocessor is microcontroller can have built-in memory, and you can save the program within the given memory space. And instead, in microprocessor, you cannot able to save any programs. So you'll be provided with a flash memory, that is program memory. You can able to transfer the instruction with the help of the available memory in processor. You cannot able to store any program inside microprocessors. So as you are using an electronic device with you, so you may be, your device may be given with processors. So those processors can access the information from hard disk, and they can able to ask your machine to provide the space to run the instructions which you are fetching from hard drives. Okay, so this processor will do this work, and it may decide what is the work which is need to work first, or in what order the instructions is going to get executed. Maybe consider in your device you are using multiple applications, like you are playing a song, and meanwhile you are playing a game, and meanwhile you connect your mobile device with speaker or any other thing. So this processor will tell to the machine that this should be worked as first, and this is the order in which the machine has to execute the instructions. Okay, so that is the difference between microcontroller and microprocessor. So since we have the program memory or the storage space inside microcontroller, you can able to store the program instructions inside microcontroller, through which you can able to control the actions of, or the output of IO devices. Okay, so that's the reason we are using microcontroller over here. So to make the difference, or to mention the difference with this microcontroller, we have used F, that is flash memory is available, and then 8. So totally we have 8 number of input and output pins. Each pin can carry a single bit input when it finds a clock source. So a single clock pulse can be with up and lower edges, and if it finds a complete up and lower edges within that pin, each pin can take one bit of input. So totally in this microcontroller, I have 8 number of input and output pins. I have totally 40 pins. Let's forget about that. We are going to deal with input and output devices. So since because of that, we are only considering the input output pins alone. So among this 40 pins, 8 pins can work as input and output pins. pins. So by using this input and output pins, you can able to transfer some inputs, either 0 or 1. If you pass 1, then it should find the source energy to transfer the input through input output pin. So the source energy which you are going to use to transfer the input is clock pulse. So a single clock pulse can be distributed to all the 8 available pins. So we can say when this microcontroller is given with a single clock pulse, each pin can take a single bit, which means we have 8 input output pins, so it can take up to 8 different bits inside 8 different input output pins. Okay, so that's why we are saying this microcontroller can act as an 8-bit microcontroller, because in a single clock pulse you can able to transmit 8 bit of information through this microcontroller. Meanwhile, you can able to connect 8 IO devices with a given input output pins. 8 different IO devices or 8 same output input output devices you can able to connect with this microcontroller. So if you are connected with 8 different input and output pins, you have to pass 8 different bits through the input output pins. So to pass the input, this crystal oscillator will help you. So until we disconnect the power, it produces the clock pulse. So in single clock pulse, it can able to take 8 different bits, and in another clock pulse it can able to take another 8 bits, and in another clock pulse it can able to take another 8 set of bits. So that's why we are saying 16F8 77A. Okay, so this is the microcontroller version. So this 8 can be used here to mention this controller can take 8 bits or 8 number of bits in a single clock pulse. So you can say this microcontroller as a 8-bit microcontroller. Okay, so because we can transfer 8 different bits through the with the help of 8 different IO pins. Okay, this can be executed with the help of crystal oscillators or clock pulse. So this clock pulse will help you to carry the data from one place to another place. Okay, so this is how this microcontroller will start to work. But all the time you cannot able to access every individual pins. Okay, so for time saving or for the pin power consumption and other things, we are designed or given with some ports. Yeah. So in big microcontroller, we have 5 ports already designed. So each of this pin connection will be shared with every ports. So we have 5 different ports. In all the 5 ports, these 8 pins can be connected. Okay, so now if you see this one, we have totally 5 ports and we have totally 8 input and output pins. If you connect 8 different input and output pins with each port, then we can calculate the pin numbers. 5 into 8 is equal to 40. Okay, so this is not the exact 40 pins which I told you before, because these are integrated circuit. You can use this 8 different input and output pins inside this port without seeing the difference. Okay, so you just created an integrated circuit in this way to execute or to use more input and output devices with this microcontroller. So that's why they have constructed the controller like this. So it is very easy. After completing this, you can understand that it is very easy. If you use any port, you can able to connect multiple IO devices. But in input output pins, you can able to connect only one IO device. But if you are willing to connect multiple IO devices, you can use different ports to connect with the device. Okay, so this is how you can able to configure, or this is what the concept of this microcontroller. So after understanding all these things, the instructions can be passed from this microcontroller to this IO pin with a memory space. Okay, for this you have to store the program inside this memory space of this microcontroller. So to store the program inside microcontroller, you have to convert the program into machine understandable code. Okay, so as you all know, we can use some of the programming languages to write the program. Okay, so here, if C is the basic program for all of these things, so we are going to convert we are going to create embedded C program based on C. Okay, so in C program, if you want to start a program, then you have to start your program with header files. So here we give this as a header file, hash include stdio.h. So here hash means preprocessor, and include is a keyword which you can use to add all the required library files into this one, and stdio is another function or method or library in which we have this one, that is the standard of input and output we can get and give. So those can be described with the help of this stdio, and then if you want, you can add this header file also, configure.h. Okay, like the same, when you work with the embedded C, you need to create a header file. So when you work with this big microcontroller, you can just make this as a header file, hash include pic.h. Okay, so within this big header file, you can able to grab all the required information or all the required library of to use this microcontroller or to create the code. Okay, so after this, we are not going to see the output in the console window, so that's the reason we can skip this Carnival.h in this place. When you work with this embedded system, you can skip Carnival.h. Okay, so after this, you have to give main function. So you can just derive the main function like this, and like the same in embedded C also you have to give the main function. So after this, you can initialize or declare the variables with some values. So here I'm just going to declare value 10 for variable A, and I'm just going to declare value 20 for the variable B. And after this, I'm just going to use operators to add these two numbers. Okay, so after this, I know that I have my output within the variable C. So here I'm just going to print the variable C to see the output. Okay, percentage D comma C. So this is the basic printf format which you have to give in C programming to view the output without any error. Okay, so these are all the, I mean, this is the basic program of C you can write. So in embedded C, you can just start to write the program. Unlike in C programming, we have only pins and ports with embedded programming, right? So we already discussed which form of thing is going to be used. I mean, which form of thing is going to be easy if you use. So you can able to write program to access individual pins, or you can able to write program to access individual ports. It will be easy if you take ports, because you can know, I mean, you know that all the 8 input and output pins are already configured with the port. So it is very easy if you use the port, you can able to access 8 number of pins with a given single port. Okay, so if you go for a pin, you have to identify or you have to configure each pin to work for the specific output. Okay, so here by considering two devices, one is input and another one is output. Okay, so if you take individual pins as 1 and 2, so in pin 1, consider we connect a switch, and then pin number 2 we connect LED. So if the switch get on, then the LED should get switched on. So this is what the thing we are going to configure, but we forget about the other 6 number of pins. So which can cause you a exception or some error, because you didn't configure or you didn't tell other 6 pins to act in any state. Okay, so that's why it can get you or it can create some interrupt and it can disturb your functions. So it is better to use these pins within this port. Okay, so if you use a port to configure input output devices, you can control the port with some specific number. The port can take control of the input output pins. And as I told you before, you can able to connect IO devices within the given pins. So it can be input device or it can be a output device. Okay, so here you need to configure the pin, or you need to configure or change the state of the pin to output if you are connecting any output based devices in that specific pin. So if you need to configure the pin as input if you are connecting any input based devices, as I told you before, you can able to use switch as an input, and LED can be act as an output device, or 7 segment display that also can be described as output device, and LCD, other kind of hardware devices you can configure as output device, and this button can be input device. So if you are converting the pins into different modes, then you have to tell other rest of the unused pins to act with a specific state. Okay. To do that, through which we can understand there are three different concepts can be applied. One is that all the 8 pins can act as output, or all the 8 pin can act as input. So some of the time you can configure 4 pins as input and 4 pins as output also. So to make the port understand what are the pins we are going to use and what are the pins need to be configured as output. So to make the machine understand that we are here, we are going to give this one 0x00. So if you use the number 0, this microcontroller can understand the port B. The 8 pins which are connected with the port B should act as output. Instead, if you use F, this microcontroller can understand that here it can able to use just give me a minute. Hello. So here, if you use 0, then you can, and I mean, the controller can understand this. The pins which are connected with port B should act as output. So I told you before that we have 5 different ports, and we have name for this five different ports also. The name of this ports are A, B, C, D, and E. Okay, so these are all the 5 different ports you can find within this big microcontroller. So this microcontroller can take 8 pins in each port, and if you want to, if you are configuring the pins as output, then you have to give 0 in this place. So after this, we cannot able to add anything within this. So instead, we can able to activate the pins and ports here. So if you want to activate a specific pin, here you can use the number 1 to activate a specific pin. Okay, so as you know, here we are using a hexadecimal number based system. So with the help of this hexadecimal number system, you can able to control individual pin with a given number. Okay, so means this hexadecimal value can be split into 4 different digits. Okay, so as you know, binary can use 0 and 1, but hexadecimal can be constructed with 0 to 9 and A to F. So totally we have 16 numbers or digits. Okay, so these 16 digits can be used to create or form a hexadecimal based number system, but it is hard if you use 16 bits all the time. So what they did was they converted all these 16 digits into 4 digits. So we can have the 4 digit like this. So inside all the, I mean, inside every digit, you can consider we have different four different bits or numbers, because you are using 16 different numbers to create this hexadecimal value. So here, if you are converting the 16 digits into 4, each bit of this 4 should carry 4 different digits. Okay, so inside this 0, we can understand 4 different 0, I mean 4 different bits are available, and the 4 can also be written as 0000. And if you take the next bit, there also we have another 4 different digits already installed with this one. And if you take the microcontroller, we have only 8 different input and output pins, so it is enough that if you use these 2 digits of this hexadecimal number. So that's why we placed x after this these 2 digits, because the machine should not need to worry about this other digits of this hexadecimal value, because it is enough that it is enough if you use these four digits. Okay, so totally we have 8 different digits within this one. So it is enough to access 8 different pins. So that's the reason here you have written in your program as 0 0 and 0 1. So here you have mentioned 0 to make the port, or to make the pins of the port to be act as an output. Okay, so if you want to make the pins to act as input, you can just use 1 instead. 0, you can use 1 to make that pin act as input. Okay, so switch can be used as an input device. So if you are connecting any input based devices, then you can configure this address be registered with 1. But if you are using any output based devices, then you don't need to give 1. Instead, you can use 0 to make that port act as an output. Okay, so after this, if you want to activate any devices, you need to give 1 or you need to give 0. So to I mean, you need to give 1 to activate the device, 0 to deactivate the device. Okay, so this is how you can write a program to execute the microcontrollers instructions and all. So for this, we have some specific softwares like MPLAB and Proteus. There we can see that we can identify the output. I cannot understand this one. Okay, then you're asking about the hexadecimal number system, I think. So it is, if it is FF, all the 8 pins can act as 1. Yes, you need to make a 0xFF if you want to configure all the pins as input. Okay, then you can create a new folder before starting to work with this softwares. Okay, so here I'm just going to create a new folder in this one. So this is the folder I can create in this place. So to work with this software, you can just download the crack file from internet of this software. This is the software which you can use to work with this big microcontroller. And if you are working with any other microcontroller, you need to download another softwares. Okay, so here what I'm going to do is that I'm just going to create a new project under which I can able to see the option to select the microcontroller. So as I told you before, we are going to work with this PIC 16F877A. So I'm just going to select this controller from here, and after this I have to select the active tool suite from this software, because I need to select a compiler from this option. So since we are working with a C based program, here we have to select C based compiler. Okay, so to select the C-based compiler, I need to set this option high-tech universal tool suite. After this, you can give next, and then you can find the browse option. There you can find the folder which you just created just now. So inside the folder, you can have the project name, which is LED. The project name alone. We don't need to give any extension, or we don't need to add any extension to save the project. Okay, so after this you can give next, next, and then finish. So now you can see some of the additional options are displayed with this window. So you can use these options whenever you need. But right now we don't need to see or to care about these options. So after creating a project, you need to create a new file. So to create a file, new file, I can just go and get into the option file, and I can find the option new. So I can able to create this new file. There you can type your embedded C program with I mean like this, into big.h and then void main. Okay, so and then you can just mention trust be equal to 0x00 if you want to configure all the 8 pins as output, and if you want to activate one among them, you can use port be equal to 0x01. If you want to activate all the 8 of these pins, you can just place FF in this place. So as you know in microcontroller, or as you know in hexadecimal number format, you can use A to represent 10, and if you want to represent 11, you can use B, C for 12, and 13 D, and 14 is equal to E, and 15 is equal to F. So by considering the number from 0 to F or 15, you can understand that we have totally 16 digits or 16 different numbers. To access these 16 numbers, we can use some of the characters if we need. Okay, so when you go with octal number conversion, you don't need to use these characters. Okay, but here we have 8 different input and output pins, so we use this hexadecimal number system as a common number system to access all the pins. So after writing the program in that window, you can save this program. You need to save this program in the same folder where you have say project. Okay, so here you need to give a program name. I can just have the same name, but will not cost anything. So but I need to save this program with the extension .c, because I converted the C program into embedded C, and I have written the program inside this file. Okay, so since we are working with the C program, you need to save this program file with the extension .c. So after this, you can just save this file, and you need to find the option source files from this menu. So this can be created if you configure your project in a proper way. If it finds any difficulty with the project creation, it won't create this source file, header file, object file, library file with your for your project. Okay, so after save your program, you can just go and right click on the source file. You can just select the file from the folder, and you can open, and then you can run this project file with the help of this option build. If it finds any error in your program, it will display the error message in the same window itself. There I can see the error message is displayed. That is semicolon is expected. So I need to check my program, verify my program where I missed this semicolon. Okay, so after all, you can just save this program and run it once again. So now you can see the program was successfully compiled. Okay, so after this, you know that we saved 2 different files inside the folder embedded. One is led and another one is led.c. But after the successful execution or compilation of this program, we can see so many other files are created with the help of this software. So here we can see led.hex. The file type is hex. Hex file is available inside this folder. You can able to embed this hex file into any microcontroller, but we already written a program. We already the header file has hash include big.h, so you can able to use this program when you want to work with big based microcontroller. But you can use this software to convert your programming language into machine understandable code, and that machine understandable code format here is that hex. Okay, so this your program was converted into hex file format. Now you can take this hex file from this folder, and you can embed this hex file into any microcontroller. So that's why we define embedded system as a combination of hardware and software. So we cannot able to explain how we can able to connect with hardware in online classes, but to explain it more, so we have some simulation software like Proteus. So I already have this software installed with my system. So now what I'm going to do is that I'm just going to start this Proteus software, and I'm just going to create a new project file from this one, and I can name this project if I want, and I can save or specify the location where do I want to save this program, and then hit on next. So it is enough. I mean, for myself, it is enough that or it can save the program in the default path itself. I don't need to worry about that. So I can just leave the things as it is. So after this, you can give enter, and now you can just select the option create a schematic from the select template, and then you can use next and create a PCB layout, and then again next, and then create a firmware project. Now you have to select the microcontroller and the family also. So here we used a PIC 16F877A microcontroller. So here you have to select this PIC 16, and then you have to use the controller version which you already mentioned in your program. So here we can see this option available, PIC 16F877A. So I can just select this microcontroller version, and then I can give next and then finish. So now you can see the schematic capture of this microcontroller. Okay, so as I told you before, so these are all named with RA0, RA4, RA5, like that. So these pins can be used under port number A or port name A, and you can find the same kind of pins available in the right side of this microcontroller also. From this you can understand this pins can be used for port B, and these 8 pins can be used for port C, and these 8 pins can be used for port D, and these 3 pins can be used for port E. So in port B, C, and D, we have 8 pins, but in port A and E, we don't have 8 number of pins. Instead, we have 3 and 6 number of pins. Okay, so this is our virtual software which you can make you feel work like a hardware. Okay, but before going to test with the hardware, you can use this simulation software to get the output. Since because of that, they have these ports are left with other pins. Okay, right. So after this, you can find this option P available inside this Proteus file. You can just select this option. From this, you can search for the LED, because right now we are going to connect LED and we are going to check the output. So here you can just double click on this LED name, and you can just drag and drop the LED name after this, and you can just make a wire connection, and you need to add ground for this LED, because we can, I mean, this LED can take possibly from this virtual power, and it has to connect it with the ground. So I can just configure ground with my LED like this. So after this, you need to create a hex file or insert a hex file. For that, I need to find the folder where I have my program installed. So here I can see this option is available, that is the led.txt file is available. So I can just open it and close it. So now if you use this play button, you can see this LED is blinking or glowing. Okay, so here I didn't turn off this LED with my program. So if you want to turn it off, you can just use port B is equal to 0x00. So you see, this is the command you have to give if you want to permission denied. Okay, so I'll close this folder. Then I'll try to build it. No, it is not doing again. Can I create hex file? Why is that? I don't know. Okay, so if you want to add this file, I mean, you can remove it. Okay, I forgot to close the hex file. So you can give 0x00. Now you can check out. So now you can see this LED is getting blink. Okay, so this is how you can write scripts to access or to work with hardware. Okay, so and also if you want to activate any other pins, you need to understand the number format first, and then you can just enter a number to activate any specific pins. So here I configured all the pins as output with the help of the stress register. So within the stress I gave 0x00, so which means all the 8 pins can act as output. And if I want to access the second pin of the port of B. So here we can use this number 2. So as you know here 2 can be divided into 4 digits, and if you write the decimal number 2 into 4-digit binary values, then you should write this number in this format. Okay, so this can be work for first pin, and this can be control this can take control of the second pin. Okay, now if you connect the LED in the second pin, you can see the output. Otherwise, it will not give you output. So here, it is blinking again. So I can just remove this connection. So now I can see the output is not running in this place, because I need to run this program again. And so now I can see this output. Okay. So when you want to connect all the 8 pins of this port, you can just mention FF in this place. So you can use all the 8 pins of this port with the help of this hexadecimal value. Okay, so this is how you'll create this program. After this, if you want to connect any input-based devices, then you have to, as I told you before, you have to give 1 in this place. And consider we are going to connect a button within this first pin. To take the button, again you have to move to this part, and you have to find this one, and you have to search for the button. Okay, it will give you the push button, and you can just double click on it, so that you can able to see the button is available inside the menu box. So there you can able to connect this button. So the another end of this button should get connected with the power supply. So for that, again you have to go to terminals mode. There you can find the power option available, and you can connect the power within this button. So after this, you can start to write your program. Okay, so in the first button, the name of this first button is known as RB0, and the name of the second button RB1. Like the same, if you go for port C, the name of the first button can be RC0 and RC1. And after that, if you want to look for the port D, and here you can see RD0 is the port number. Port name, pin name of this port. Okay, so as you know, you connected this button with only one pin, RB0. So if you want to access an individual pin with your program, then you can use the name of the pin to take control of a individual pin. If RB0, like that, you can able to enter, use the pin, individual pins in your program. So here also I have used individual pin, but I know that the starting or initial state of this button is with 0 or off. Okay, so in the format of number, if I want to define this the state of this button, then I can say this button is in 0. Okay, if it connected, then I can say the state of this button in 1. Okay, so now I know that the button state is 0. So I need to check this one. So I need to check this one. So here, to verify the button's input, here you have to give if RB0 is equal to 1. So this is what the thing I can give, because I know that this button is in 0 state. If the button is activated by the user, then it has to activate the LED. The LED is already connected with pin number RB1 and it has to start. Okay, else it has to stop. So else RB1 is equal to 0. So this is how you need to construct a program, because we have decision making statements in C program. So you can use the same to control the IO devices actions if you want. Okay, so here you know if the condition satisfied, then this statement will get executed. Otherwise, the else part of the statement will get executed. So here I have given the condition as RB0 is equal to 1. So I know that the initial state of this button is 0. So when it finds the value 1 in this button, then it has to activate the next pin. Okay, so after this, I'm just going to compile this program. So here you can just play this, and if you connect this button, you can see the LED is glowing. Okay, so this is how you can build embedded systems based program. But we didn't consider internet in this embedded systems applications, because with the help of the internet you can able to transfer the input from one electronic device to another destination place. The destination place can be a server or a database. Okay, so if you want to transfer a hardware's output to any other place, then you need to have an option to connect internet with your hardware. This big microcontroller does not support internet connection. So that is the disadvantage we have with this big microcontroller. Then, which device can we use to connect the internet and to access the options of this microcontroller? So the device which was already configured with internet is Raspberry Pi. Okay, so you can use a Raspberry Pi board to connect internet, and you know that a Raspberry Pi can be a mini computer like this. So I can just Raspberry Pi. So this is the image of this Raspberry Pi. Okay, so inside Raspberry Pi, you can just see the hardwares available, and here we can see two different USB ports are given, and through this USB ports you can able to insert USB drives if you want, or you can use USB based keyboard and USB based mouse. Okay, to access this board's content, you can use these USB ports to connect your USB devices. And nearby this USB devices, we can find this LAN port available. So through which you can able to access internet. So we have more different models of this Raspberry Pi, like Raspberry Pi 0, 1, 2, 3, 4. And in the models of 0, 1, 2, 3, 4, or under the model 0, 1, 2, 3, 4, we have variety of options like Raspberry Pi A plus, B plus, B1 plus, B2 plus, like that. We have variety of controller boards, or I mean Raspberry Pi boards versions. So the difference between the different models or can be, or you can able to access Wi-Fi if you are using Raspberry Pi 4. And in Raspberry Pi 3 also you can able to access Wi-Fi, but in Raspberry Pi 2 you cannot able to access Wi-Fi. Instead you can able to access only internet. Sorry, Ethernet. Okay, so you could be allowed with LAN cable, LAN port alone. So through the LAN you can able to connect this one. Connect. I mean, you can able to get internet access with this Raspberry Pi board. Okay, but when you use latest version of board, you can able to use Wi-Fi drivers to connect internet with this Raspberry Pi. And you want to see the output of this Raspberry Pi board, right? So to view the output of this Raspberry Pi board, you are already given this Raspberry Pi board was given with HDMI port. So you need to find a converter from HDMI to VGA. If you are connecting this Raspberry Pi board, or if you are viewing this Raspberry Pi board's output to monitor, you have to find a convert cable. Otherwise, if you are connecting your Raspberry Pi board with TV, by you can connect this device into TV also. If you are connecting this Raspberry Pi board and you are viewing the output of this Raspberry Pi board in TV, you don't need to get a converter cable. Instead, you can use HDMI to HDMI cable, through which you can able to view the output of this board. And to give the power supply, we have C-type Type C port with this Raspberry Pi. And in Raspberry Pi model 3, you will not be given with port C. Instead, you will be given with port P. Okay, so the small pin which you need to use to activate this Raspberry Pi board. After this, you can see some number of pins are available in this place. So the total number of pins which we have in all the Raspberry Pi board versions are 40. Okay, so all the Raspberry Pi boards are given with 40 number of pins, and the I mean, if you search for the pin configuration, you can identify the purpose of the pins. So Raspberry Pi pin configuration. Okay, so this is the basic pin configuration image. You can get it from internet, and you can understand what are the pins. And so okay, so here you can find this one. So you can use these two pins as 5-volt power supply, and the next pin as ground, and GPIO 14, GPIO 15. So the GPIO is known as general purpose input output pins. So with the help of this general purpose input output pins, you can able to connect all the IO devices. And with the help of the IO devices, you can able to with the help of the internet, you can able to transfer the input or output state of that input output devices to cloud, or to server, or to database. Okay, so here this is the option we given with. And if you want to access any 3.3 voltage 3.3 volt based device, then you can use this pin. Okay, so as you know here, the pin numbers are getting differed. It was not available in a given order, but it may be. Yeah, they configured this pins with a random number. So here you can see GPIO 14, GPIO 15, GPIO 23. So when you write a program, embedded C program, or any specific program to work with this Raspberry Pi, then you have to mention the pin name as GPIO 21. or GPIO 13. So here you know that this can be constructed like this. Okay. So if you see this video file in here, you can understand some of these things. So here a toy was designed with Raspberry Pi. Okay, so you have to train or you have to write the program inside a Raspberry Pi to make this make the Raspberry Pi to understand the voice or any other commands. So as you can see here, if the ball is rotating in some other place, the toy can watch that. Okay, so to do that, you have to use these kind of pins and things to access these modules. Okay, so this is where you can use a Raspberry Pi board. Okay, so you can get more output from this one. And if you want to make any home-based devices or home-based automation, you can just configure all the home-based automation with the help of this one, like Raspberry Pi. Okay, so these are all the things you can create with the help of this Raspberry Pi. Okay, so this is how we can able to use this Raspberry Pi board to build all the required things. So some of the home automation product manufacturing companies are available in industry, and the companies are using this Raspberry Pi to create home automation based products. Like if you are entering into any room, the device or the this Raspberry Pi board will start to analyze the light brightness of the room, and if it finds the low value, then it will automatically start the light. And if it finds the temperature is very high, then it will automatically instruct the AC to turn on. Okay, so these are all the projects you can do with the help of this Raspberry Pi. And the most important thing you have to know about this Raspberry Pi is that this Raspberry Pi can work under or work with the individual OS called Raspbian or Noobs. If you are if you want to use any other OS than Raspbian and Noobs, you can install Windows 10, or you can use Linux family, all the Linux versions of OS. Okay, so this Raspberry Pi board can support all the versions of Linux OS, and this Raspberry Pi board can work under Windows 10 also. But it won't support Windows 8 or 7 because in Windows 7 or in 8 we don't have the packages to access GPIO pins. So that's the reason we cannot use the older version of Windows in this Raspberry Pi. But better you can use Raspbian or Noobs to know all the or to use all the advantage of this Raspberry Pi board. Okay, you can use that one. So other than this, to install the OS within this Raspberry Pi board, you need to have a micro SD card. Inside the micro SD card, you can have the OS installed. OS installed, you can use it. So here you can use this one. So raspberrypi.org. So I am just going to give Raspbian download. Okay, Raspbian download. So inside this raspberrypi.com, I can see the software field, and inside software, if you go through this, you can find this Windows imager file available. So you can download and install this Raspberry Pi imager, and through which, if you connect your memory card or micro SD to this Windows machine, you can able to access or install this OS with your file. I think I have the image file installed in my machine. You know, I don't have that one. Okay, so you can download if you are installing Raspbian through Windows system. Okay. Otherwise, you can just have a card reader. Inside the card reader, you can place your micro SD card, and you can make the micro SD card as bootable. And after that, you can copy the software, or you can download the software from this URL, and you can copy and paste the URL into that micro SD card, bootable micro SD card. So after that, you can remove the SD card from the card reader, and you can place the micro SD card inside Raspberry Pi, and if you give the power supply to that Raspberry Pi, it will ask you to give instructions to install that Raspbian OS which you downloaded. Okay, so without making the micro SD card bootable, you cannot able to install the OS. Okay, so to make the SD card bootable, here we are using this one. Okay, so these are all the advantages or features we can use. So here, by considering this size of board, you can able to run Windows OS, Windows 10 if you want. Okay. So by comparing this with a laptop or desktop, you can see the size of this Raspberry Pi board is very minimized. Okay, so that's why we are saying this can be a small computer. Okay, so it will be very easy to carry, and it will be very portable. You can use these kind of things to use. Okay, so after all this, you need to know the threads of this one. Just give me another minute. Okay, so from this you can understand how we can use this Raspberry Pi board and all. But yes, and next we have to consider the programming language part. So since we are using a different OS, you cannot able to use C program to make this work, because C need to have its own compiler to work with this one. Okay, so when you work with I mean, when you want to work with Windows-based machine, you have to use a proper compiler like I mean Turbo C++, their C compiler you can use to execute the program. But when you use Raspbian OS in Raspberry Pi, you will not be given with any specific compiler to work with the C program. So instead of using C, you have to select a platform independent programming language. So most, I mean. Other programming languages like Java and Python can be act as platform independent programming language. So you can use one among them to create Raspberry Pi based program. But the number input and the pin configuration and other things are same as like a big microcontroller. Okay, so there is nothing is going to get changed because you are using a different OS, and this Raspberry Pi is already built with a processor. That processor can work the processor can take the code or can make the machine work. Okay, so here you can use Python program to build programs or to activate or deactivate your IO devices. Okay, so this is the basic thing you need to know. And then when you connect with the internet, you can understand that the router can allocate IP address for this device too. Okay, through which if you could identify the IP address of this Raspberry Pi device, you can able to check for the vulnerability with the help of Nmap or Nessus. Okay, so since we are using a different OS than Windows or Linux from this, with this Raspberry Pi, the Raspbian OS was not built with all the security measures. Unlike Windows, they have a less number of security rules within the OS. So you can try with this Raspberry Pi, and you can easily hack this Raspberry Pi board if you want. Okay, so that is the threat we have with this Raspberry Pi board. Like the same, if you want to access internet with any other hardware, you can use uh, Arduino Node MCU. Okay, so these are the board names which you can use than this Raspberry Pi to connect the hardware with the internet. But the most commonly using hardware is Raspberry Pi. And the Raspberry Pi, if you use this Raspberry Pi with internet, this can give you, the router can allocate IP address for this Raspberry Pi board. And if you could identify the Raspberry Pi board's IP address, you can use Nmap or other tools to identify the vulnerability. So if you find the vulnerability, you can able to break the OS security rules, and you can able to capture the information which are available inside the memory card or in the SD card. Okay, so if you could identify the or if you could exploit the information which are available inside the SD card, you can able to find the program. Okay, so consider I'm just going to create a IoT based vehicle. Okay, for to make the vehicle run with less power consumption, I can use this Raspberry Pi board. Inside the Raspberry Pi board, I can have my program, and by accessing this micro SD cards program, the IoT vehicle can drive. Okay, so if you could exploit the memory cards information of this Raspberry Pi board, you can able to extract the program of that micro SD card, and you can change the micro SD card program as per your need. So the hardware electronic device cannot change the program, but what it can do is that it can take the instruction from micro SD card and it can act like that. Act as the instruction it is getting from the micro SD card. If you could exploit that SD card and if you change the program yourself within that Raspberry Pi board, you can able to break that IoT devices with the help of this Raspberry Pi. Okay, so this is the major issue which we are facing nowadays with this IoT based devices. And consider in some industries they are using this IoT based sensors like temperature or any other sensors. Okay, so if they could break into their network, they can able to identify all the informations available inside the SD card. And I already explained you where you can find the vulnerable Raspberry Pi board's information. So you can use this Shodan to identify the vulnerable Raspberry Pi information. Okay, so here inside Shodan, I can search Raspberry Pi. So in India, we can find some of the devices running with the help of this Raspberry Pi. For that, you have to so seven results we have. Okay, so this Raspberry Pi board is using Airtel's internet connection. Okay, so you can find some of the vulnerability of this board if it is available. So I already explained you with the help of this Psi network. So you can see the open ports of this Raspberry Pi board. Okay, so you can try using this port, and if you could enter into the network with this port, you can able to access all the available informations. So this is where hackers can collect the information. Okay, so these are all the things you need to aware of, and with the help of this Raspberry Pi board, you can able to build robots and all other things. If you want, you can construct with the help of this Raspberry Pi board. Okay, so I'll just explain the things more with the help of the PPT. So closed it. Yes, I think. Okay, so I think I have the PPT in this system itself. Just a minute, I'll just take the PPT. Okay, so I have the PPT in here. Okay, so Internet of Things, you already know it. IoT is the name for the internet interconnections of devices to networks, and the internet allowing devices to send and receive information from one another. So the things can be hardwares, and internet, and with the help of the internet, you can able to transfer information from one device to another device. So this is what IoT called. And need for IoT security. So IoT devices can contain a lot of sensitive user information. Because you are connected your Raspberry Pi board with the internet, and you are sharing the Wi-Fi connection, and through which they can able to break into your router, and they can able to find the home user information of your network. And security measure cannot provide complete protection. The Raspberry Pi's security measures is not up to that level. So even if you have some basic version of security rules, it is not enough to secure all the information of this Raspberry Pi or IoT based things. And new attack methods can arise that the devices are not protected from. Okay, so it does not have periodic assessment of vulnerabilities, and also it does not have updates on security threats. Okay, so since because of that, you can easily break any IoT device. The growth of IoT, so you can see nowadays. In everywhere we are using this IoT related components or devices to make it work to make our work very easy. Okay, so from anywhere, if you want to access any data, it can be given you with the help of this one, IoT. Challenges. So, no standards for IoT hardware and software. If you use any Wi-Fi, you'll be given with the standards. And if you use LAN cables to transfer internet packets, you can able to. I mean, you can see the standards are available, but there are no standards available for IoT-based devices like Raspberry Pi or for any other boards. We don't have any standards. So, if we have standards, they can define a rule and they can. Consider all the available all the required things of the board to be used by the users. Manufacturers are relied on for upgraded security and can stop supporting security updates. So that's what I already told you. IoT devices can be small and inexpensive. So this is not a challenge, but you can take this as an advantage. Like IoT devices are so small, and wherever you need to implement the IoT circuit, it can be possible with a small space, and this can be less cost effective. I mean, it can make you small cost to build any IoT based devices. Okay, so and then minimum functionality can result in security being a second priority. So you need to consider about the security. That is the thing. So what are the main cyber security vulnerabilities of this IoT devices? So and we will discuss about all these things. And sorry. How can the vulnerabilities of IoT devices be exploited to retrieve sensitive data from the device? And what type of sensitive data can be retrieved from IoT devices? And how can this information be used when stolen? And what are the best ways to improve the security of IoT devices to reduce vulnerabilities in future devices? So these are all the major questions we need to consider and we need to improve with IoT devices. Okay, so and smart TVs. Nowadays, smart TVs are using this. IoT based devices like if you does not have any Android based devices, you can just add Amazon Fire Stick and any other third party device you can use to make your normal TV as a smart TV. Okay, so if you do that, that small device can take control of your TV. Okay, so with the help of that one, you need to aware of that whether that device has security updates or whether the device is running in any specific OS or not. So those are all the things you need to consider. And smartwatches, the smartwatches can also I mean can use to read the information or it can collect the data of your of human body. Okay, which can share the data to the medical field that you are affected with this I mean you don't have the enough energy or enough value for this thing, so you need to take care of your thing. Okay, so I mean take care of your health. So the data of that smart watches can be transferred to the other persons or other departments like medical and insurance related things. And smart cars, as I told you before, if you could get into that device, you can able to break into the micro SD card and you can able to get the information from which is available from the SD card. And 3D printers, you know that. Data retrieval methods: fuzzing, spoofing, editing the device's firmware OS. So if you edit the firmware, if you edit the OS, you cannot able to retrieve the data. So if you are not protecting the SD card of this Raspberry Pi, you won't able to retrieve the data. Or if you receive any virus file with your Raspberry Pi board SD card, then you cannot able to retrieve the data. Okay, so you have to have a cloud account. In that cloud account, you have to redirect all the informations of the SD card with no time. Okay, so if you transfer all the informations within that cloud, you can able to protect your information. So this is how you can able to protect your information of this IoT device. So and then most of the time IoT devices is used to build a home automation, like switch on the light and to set the alarm and to set to on the air conditioner and everything. Okay. So and then many possible security risks of this home automation are: remote disable of security cameras or alarm system, detecting when the user is not at home, unlocking electronic locks. Okay. So if it finds any other input uh, inside my home when I not when the human is not available, it can able to switch on the device even if the human is not. Even if the situation is not required, it cannot discover the situation and it can able to run. IoT security frameworks, or there are some of the IoT security frameworks are available, but which you cannot able to configure with Raspberry Pi or any other IoT based devices. So, but still, the IoT security framework and tools can provide this much of options, like recommendations for how to secure your IoT device, and provides a method to find flaws in devices where they do not meet the framework's recommendations. So, and after that, generalized security framework cloud help create standards. So, must consider all possible IoT network connections. Okay, the next thing is IoT network connections. You need to have a cloud account to which you can able to store the information of your IoT, and inside the cloud you need to build security measures to protect your data. And then core network, you can use routers, switches to share information to share internet with multiple electronic devices. Fog network, so that is also another method you can use to connect all the all the electronic devices together, and through which you can able to uh, create a IoT based application for your need. And Cisco suggested framework: authentication, authorization, network enforced policy, and secure analytics. So these are all the Cisco enabled, Cisco suggested frameworks, which you need to consider when you build IoT based system. Okay, so Cisco is the one of the most leading network devices manufacturers company. So they can build their own rule to secure their network devices. Okay, like the same, you need to have some specific rules, and you need to set some specific responsibility for the network device which you are going to use for IoT. And embedded security framework and architecture. So this is the basic architecture of embedded systems, because the devices which you are going to embed with your IoT device. Okay, because the IoT system can be constructed with the help of electronic devices. So you may use electronic sensors, or IoT sensors, or you may use any other circuits to take control of IoT device, or any other hardware, or any other electronic device. So while transmitting or while taking control of any data or any hardware, you need to transmit and you need to receive the data with the encrypted format. So if you don't have one, you need to build one encryption algorithm to work with this Raspberry Pi, through which you can able to avoid hacking of your IoT devices information. Okay, so and then physical security. So you need to find a secure way to use your physical device, and then secure OS. So if you are using Raspbian or Noops based OS in Raspberry Pi, there you cannot find any security patches available or any security rules available. Instead, what you can do is that you can able to install Windows 10 with a SD card, and you can use that Windows 10 into the Raspberry Pi board. But if you use Windows in your Raspberry Pi board, you have more difficulty than working with Raspbian or Moops. You'll find more difficult things because you need to configure everything yourself when you use Windows in IoT based devices or Raspberry Pi or in Raspberry Pi. And secure storage. So, as I told you before, you can use any one of the cryptography tool or any one of the cryptography method to encrypt the information which you are having inside your SD card. Okay, if you could save the information, even if they break the IoT device, they cannot able to get the information of from the SD card. And then expanding on the framework, so event reporting. So if it finds any attack or if it find anything unusual with the device, it has to give you the or it has to notice you with the error which the device is facing. And then security management and updates. So this is one thing we discussed already. And anti-DOS. So you need to set your device which can protect you from DOS attacks. Firewalls. You need to build basic dedicated firewall for this IoT based devices. And then finding devices, attack vectors, Wi-Fi, Ethernet, Bluetooth, through which you can able to identify the IoT device information. Or you can use footprinting methods to identify or footprinting tools to identify the IoT devices information. And difficult to know whether not a device will be useful to the research. So it is not the actual device which we need to research, but we are already facing more issues. But we need to set rules, and we need to define the security measures to protect all these IoT devices. So TP-Link, smart LED bulb, and smart plug. So these are all the basic IoT-based devices you can get in from the market. And then Wi-Fi camera and yeah, door lock system. ARP spoofing can be done for this IoT-based devices, and you can do man-in-the-middle attack also. Bluetooth sniffing. So you already know that I already told you use website Rubberducky to buy all these kind of devices, hacking devices. Okay, so that's it. So this is the basic thing of this IoT based security. We have Raspberry Pi hardware in our institution. I cannot able to display uh, when we have online classes. So but you can able to understand the information of this IoT security and importance of the IoT security from this one. Okay. So you can leave break now, and we'll meet after break.
Sir, can we continue the session?
Yeah, sure. We'll,
Okay.
start. So actually, I'll show you some video to work with this Raspberry Pi board. Okay, so you can find some YouTube channel with the name Network Chuck. There you can find most of the details of this Raspberry Pi. Okay, so I'll just show it to you. Okay, so I'll okay, I'll share it with my another screen so that you can have audio. And also, you need to use Raspberry Pi to work with this IoT based things. Okay, so I'll just enable it now. So when I place two devices nearby, it can cause more noise. So we'll check it. Can you hear any audio now than my voice? So
It's echoing, sir.
Anything from the 0 to the Pi 4. Now, there are some considerations you got to think about when you pick your Pi. And I always recommend just to have the Raspberry Pi 4 because it has everything you need. Built-in Wi-Fi, Ethernet ports, and it's stinking fast. And it's going to give you the best performance. So get the 4, but it supports everything, which is so cool. And also, like every Pi, you're going to need some goodies, like the power supply, a micro SD card, a USB micro SD card reader. And if you don't already have one, make sure you have an Ethernet cable and a computer you can connect to with that Ethernet cable. But normally when you're buying a Raspberry Pi, it comes in a kit and you get all this stuff right there in the package. Second, and this is pretty important, you'll need a USB Wi-Fi adapter. And you'll need one that can work with the Raspberry Pi and specifically OpenWRT. Now, personally, I can recommend this guy right here. I just bought him from Amazon. He works. Check the link below. How much was he? Let me check. Oh, he's like $12. Yeah, get this guy. Now, you may already have one and it might work, but I can't promise it'll work. And as we're walking through our steps, you'll find out pretty soon if it does or it doesn't. And then finally, you need coffee. I'm sorry, it's just required. If you do anything in IT, you have to have coffee. Networkchuck.coffee. Coffee break to fuel up. Let's go.
Become the master of all trades. AWS, Azure, and Google Cloud Platform. And Jacob.
Let's do this. Now, real quick, before we start, I'm going to show you how this is going to end up working. Now, I'll be using a Raspberry Pi 4 for this project. The key considerations here is that it has built-in Ethernet, of course, and built-in Wi-Fi. And then we'll also have a USB Wi-Fi adapter that will plug in right there. So we'll end up having two Wi-Fi interfaces. You will need two Wi-Fi interfaces. So if your Raspberry Pi does not have Wi-Fi built in, Well, you're going to need two wireless adapters, two USB wireless adapters. Because here's how it's going to work. The onboard Wi-Fi, the one built into my Raspberry Pi 4, that sucker will connect to any public Wi-Fi available. That wireless will be used to connect to public Wi-Fi. The USB wireless adapter will be giving me and my family Wi-Fi. It will be the one broadcasting my SSID and what I connect to get access to the internet. And the Ethernet port will just be part of it. He'll be part of that same network that my family is connecting to. So if I did want to plug in something to that, for example, I'll be plugging in my Raspberry Pi NAS to that Ethernet port so I can watch Plex movies on the road in the car with my family. That's going to be awesome. Anyways, here we go. So again, if you don't have two Wi-Fi interfaces, you'll need them. Okay, step one, we got to bake our Pi. We got to put OpenWRT on the sucker as the OS. So real quick, again, links below for everything. Go out and find your OS. Match it up to your particular Pi. For me, I have the Raspberry Pi 4B, which is right here. I'm going to download this firmware right here. Boom. And it's super small and really fast, so watch this. So I'm going to take the... Dang, it's already done. Okay, time to write the sucker to our SD card. So grab your micro SD card. Where'd my... Oh, there it is. Get your USB micro SD card reader, slide that bad boy in there, and plug it into your computer. And then we'll use my go-to tool for imaging anything with the Raspberry Pi, the Raspberry Pi Imager, link below, Mac, Linux, Windows. First, I'll choose my OS, which is the one we just downloaded. So I'll hit that, and I'll scroll all the way to the bottom and select Use Custom. We're doing something custom here. You want to select the OpenWRT image. Open that, and then finally select your storage. Make sure you pick the right one. Mine is this 32 gig micro SD card, and that's it, guys. Click on Write, Yes. It's super fast coffee break because this thing goes so stinking fast. Here we go, bam! And the time it takes to sip a cup of coffee, it's ready. Grab your micro SD card. Grab that sucker, slide that into your Raspberry Pi. Depending on what model you have, it might be a bit different, but I'll slide mine in here. Now the cool part is you won't need a monitor or keyboard to get the sucker going. So first what we'll do is take an Ethernet cord, plug it into your laptop or computer or whatever, and plug that into your Raspberry Pi's Ethernet port. Oh, love that sound. And then we will plug in the Raspberry Pi power. And that sucker will boot up automatically. So now how do we access our Pi with this new OpenWRT OS installed? Well, again, right now you should have an Ethernet cable going from your computer to your Raspberry Pi's Ethernet port. By default, your Raspberry Pi will have an IP address of 192.168.1.1. Our goal right now is to be able to access that IP address so we can configure that bad boy. So what we'll need to do is give our computer, our interface, an IP address in that subnet. So what I'll do is give my computer, and you can follow along and do the exact same as me, the IP address of 192.168.1.10. Let's go do that right now. I'm going to do it inside Windows. I'll do Windows key S and search for Control Panel. Click on Network and Internet. Click on View Network Status and Tasks. And then my Ethernet port is the one I want to change right here. Click on Properties. Find my Internet Protocol version 4 adapter there and change it from automatic to manual. 192.168.1.10. Default gateway of 192.168.1.1. And that's all we need. Click OK. OK, and close, and we should be able to access it. So now, and by the way, if you're using Linux or Mac, it'll be different, right? So Google that. I can only show so much. Anyways, so now I'm going to launch my command prompt or CMD for Mac or Linux. That'll be terminal. See, I'm helping you a little bit. And we're going to SSH into that bad boy. So the command will be SSH. Default username is root at 192.168.1.1. And here we go. Type in yes. And we're in OpenWRT on our Raspberry Pi. Are you ready for this? Coffee break, just real quick. Notice it did not prompt us for a password. Super insecure. Let's go ahead and change that. Type in PASSWD, which by the way, that's how you change a password on any Linux device. And that's it. Just hit enter. It'll prompt you for a new password. Enter your new password in. Something good. Password for root, changed by root. Now, whether you're new to networking or not, OpenWRT is fun. Like, it's a new thing. I'm used to Cisco stuff and Ubiquity. This is all like Linux. So check it out. First, I'm going to show you something. We're going to do CD or change directory. We're going to go to /etc or /config and just go there and enter. Type in ls to see what's inside. All these files right here hold our configuration of our Raspberry Pi router, our network config, firewall, DHCP, and we can edit these files. So let's take a look at network first, and we're actually going to make some changes here. Actually, no, first, what we're going to do is back up our files in case we screw something up. So here are the files we're changing, and we want to back up. Wireless, network, and firewall. Really easy to back those up. Check it out. The command will be CP, which stands for copy. We'll do firewall first, firewall, and then we'll say the name of the file we want to copy it to. Firewall.bk for backup. Done. We backed it up. Let's do it again. Do up arrow. Do it for network. Network.bk. Backed up. And we'll do it for wireless. So now if we hit ls once more, we get our main configs and we got our backups right there. Perfect. Now we're ready to make some changes and not be too afraid of what happens. And worst comes to worst, you can always re-image it. Did you see how fast that was? Like, so it's not a big deal. Now, real quick, let me tell you something. As we're doing this project, as we're building a Raspberry Pi router, did you know that you're building some crazy skills, marketable skills like Linux and networking knowledge that you can put on a resume, or even better, a website? Yes, these are skills that can help you get a job, but you can't get a job unless someone knows about you, unless someone can see what you're doing. I truly believe having a website with your name, with your branding, is the best way to get your best foot out there. Sure, you can have a resume, but man, having a website along with your resume puts you above the rest. That's why I'm a big fan of Hostinger, the sponsor of this video. They are a fantastic way to build your website. In fact, all of my daughters, 5 of them, yes, I have 5 daughters, have a website on Hostinger right now, because it's never too early to start branding. From 4 months old to my 10-year-old, yeah, they have their own website. And if my 4-month-old has a website, I think you should have a website. And choosing Hostinger for that website is a no-brainer. Fast servers, 99.9% uptime guarantee, which you want to keep your website up. It's optimized for WordPress, which is what I run all my websites on. It's the best thing ever. And if you get lost, they got chat support 24/7, 365. They have a crazy user-friendly control panel. Everything's really easy to set up. I even made a video about this. I made a video telling you why you need a website, and I showed you how you can do it. So check it out somewhere up here. You also get a free domain, SSL, and a 30-day money-back guarantee. So yeah, don't waste any more time. As soon as you're done building your Raspberry Pi router, go build yourself a website. In fact, talk about doing this. You'll be amazed at what employers will look for. If I were hiring someone right now, if I saw that, dude, you're hired. So check it out in the description. I got a link for you. Hostinger.com/networkchuck. Use my code networkchuck and you get 10% off. Let's jump into our network file first. Now, bad news. Nano, he's not here right now. My favorite text editor in Linux. We have to use VI or Vim. Let's do it. So type in VI. And then the name of that file, network. That's it. Hit enter. We're in. All this right here is our network configuration. It's cool, right? So let's make some changes. Okay, first we're going to change our LAN network here. One thing we're going to change is the IP address. 192.168.1.1 is the most common home network IP address or subnet. And you know what? Hackers know that too. So we're going to change it so they don't know. So we're going to use our directional pad to scroll down there. And to make this edit change, we're going to hit the I key for insert. Insert. And now we can start editing. So I'm going to backspace that IP address and put in a custom one, like 10.71.71.1. You can copy me if you want to, just make sure it's a private IP address. And that's all I need for that network there. And then we're going to add one more line here. So go ahead and bring your cursor with the directional arrows all the way down here to the bottom, right here. Hit enter and then space on over to where it all lines up nice and pretty. I just like the way that looks. So here, type in option and then type in force_link and then space, single quote, 1 single quote, which we're basically saying this is his IP address, keep this config, save it, whether he's up or not. So he's done, he's good. Now hit enter a few times. We're gonna make a new interface. You ready? Oh, this is crazy. All right, here we go. We're gonna copy what we just did up there. Type in config, interface. Now we're gonna name this new interface, single quote, WWAN or WWAN. Single quote once more to close that sucker out. Hit enter, line that option up with the N, type in your first option. Oh yeah, we're gonna add some config to this. We're then gonna type in proto, PROTO, space, single quote, DHCP, single quote. Now what this is doing here is we're telling our WAN interface to pull an IP address from DHCP from whatever wireless network we connect to. So if it's public Wi-Fi, like Starbucks, boom, it's gonna give your WAN interface an IP address. Whereas up here on our LAN, we're doing static. We want that thing to stay the same. Here we wanna match it to whatever network we're connecting to. Golden. Now for some more options. Hit enter, space on over, space out. Option, we're gonna type in peer DNS, space, single quote, 0, single quote. And then one more time, enter, space on over, option, we'll type in just DNS, single quote, and then we'll put in a DNS server we wanna use for our WAN interface. Me, I love to use Cloudflare's 1.1.1.1. You can use that as well. And then as a backup, I'll do Google, so space 8.8.8.8. Cloudflare and Google, can't go wrong, right? I don't know. Okay, we're done with the WAN interface. We're gonna add one more. This is a promise. Config, interface, single quote, VPN, client, because we will be setting up a VPN connection. Now, if you're not gonna do VPN, then you can skip this part. I am, because I wanna be secure. Because we know hackers hack Starbucks Wi-Fi all the time, right? Anyways, hit enter, space on over, option, if name, we're naming an interface, single quote, ton, 0, single quote, and then one more, option, proto, single quote, none, single quote. Now that's it, we're done. Now just so you know, all we're doing here can be done in a nice pretty GUI. So if you're more comfortable with that, go for it. And we're going to do both with this tutorial. I like doing both. Oh, it's so fun. Anyways, I'll show you the GUI here in a bit. So now how do we save this? We're using Vim, so it's a little unfriendly, but to do this, don't do anything just yet. Just calm down. First, hit the escape key, then hit colon, then type in WQ. I know it's freaking weird. Right here at the bottom left, you should see it just like this. Squiggly, colon, WQ. If you see that, you're good. Hit enter. You did it. You saved the config. Now, real quick, we're going to make one change to our firewall. So again, we're going to do VI. This time we'll do firewall as the document we're going to open. Do it. We're only going to change one thing. Down here, we're going to change configuration for this zone right here, the zone for our WAN. We're going to change this option input from reject to accept. That's all we're doing right here. So again, scroll on down with your directional arrows. Get in place right up here next to that reject. Hit I to start editing. Remove that, type in accept, and then we're ready to save. Hit escape colon WQ, enter, we're solid. Now we're going to reboot our Raspberry Pi. And when it comes up, things are going to be a bit different. It's going to be fun though. Ready? So first let's type in reboot, and that's it. Hit enter. Bye, buddy. See you in a minute. Okay, and you should lose connection. We just did something that's going to affect how we connect to him again. His IP address was 192.168.1.1. I changed mine to 10. What was it again? I don't remember. Was it 77? Let me go look through this again. I don't remember. 77 or 71, one of those two. So we'll need to be on the same network in order to connect to that guy. Now the good news is that network is handing out IP addresses like candy. DHCP suckers, so all you gotta do is change our adapter back to DHCP. So here in Windows, I'll get back into my Ethernet adapter, go back into his properties, get back into his IPv4 stuff, and then change it back to obtain IP address automatically. Okay, actually I'm gonna change it back, my DNS too. Yes, we're all good. Okay, close, and now we wait. Here on Windows, I'll see if I got anything yet. I'll do IP config, take a look at that interface. Okay, it was 71. Yeah, here I am right here. It gave me 10.71.71.247. And I'm gonna connect to him on 10.71.71.1. Let's try it out. So the command will be SSH root at 10.71 or whatever you set yours to, 71.1. Yes, and then my password I set earlier, boom, we're back in. So now here's the state of things. We got our new IP address on our Raspberry Pi, our new subnet, our new LAN, and I have a new IP address too. Exciting. Now our next task is to get our USB Wi-Fi adapter set up. Now you might think it would be as simple as just plugging it in and magic happens, it works. No, IT is rarely that easy, but we got coffee. That's why we have coffee. Anyways, coffee break. Well, the good news is it's not too crazy. All we have to do is install a few drivers. So let's get this guy back on over here. We're not ready for him yet. Just a moment, Bubba. We'll have you up there in a moment. First, we got to download some drivers. Now, to download drivers, we'll need internet access. Our Raspberry Pi is going to need internet access. So our task right now is to get his internal Wi-Fi adapter on my Raspberry Pi 4. I want to get him connected to my Wi-Fi here in my house. It's actually crazy simple. Check this out. Watch. Oh, it's so fun. So back at our terminal here, we're going to make one change to our wireless configuration. So we're going to do VI once more. We'll be done with VI here in a moment. Don't worry. Actually, we'll keep using it just for fun. VI, we'll do /etc/config/wireless, and we're in here. We have to make one change to our Radio 0 interface, which is the default built-in one to the Raspberry Pi. We have to make this change in order to make him come up and work. I ran into this issue and I couldn't figure it out until I found this awesome forum with this awesome answer. Here's the answer right here. Let's make some changes. So first, we're going to change our channel. Right now, it's 36. Hit I when we get there. Change it from 36 to something like 7 or yeah, just do 7 for now. You can change it later. We'll change our option HW mode right here from 11A to 11G. Then down here, option HT mode, we'll change it from VHT80 to HT20. And then we'll add one more line underneath option disabled. Let's do it. Enter, space on over, option. We'll type in short _GI_40 and then space, single quote, 0, single quote. That should be all we need. Now, if you know anything about me, I hate wireless networking, so don't ask me what that meant. I just know it fixed it and it works, and that's really all I care about. So we're gonna hit escape:WQ to write and quit to save it and get out of there. We're golden, and now we have to apply that configuration to our wireless interface. A few commands here. First will be UCI commit wireless. We're committing our configuration, saving it. Bam. And then just type in Wi-Fi. Boom. You know what? We forgot one thing. Hold on. Let's get back in there. VI, etc, etc config wireless. We forgot to enable it. So right here, notice it says option disabled 1, which is like binary. It's like 1 is on. So yeah, option disabled. It's disabled. Let's enable it. So we're going to turn that 1 into a 0. Hit I, change that 1 to a 0. Escape:WQ out of there. And then we'll do that same commit thing. UCI commit wireless, type in Wi-Fi. Okay, cool. That's a lot better. Okay. Now real quick, just for fun, if you pull out your phone or something that has wireless, and you go to look for your wireless connections around you, you should see something that says Open WRT. Yep, there it is. It's broadcasting. Super cool. Okay. But now we're going to take that connection and make it connect to your Wi-Fi, my Wi-Fi, to get an internet connection. For that, we're going to the GUI. Here we go. So fire up that web browser, navigate to the IP address of the Raspberry Pi router, 10.71.71.1. Hit enter. Oh yeah, here we go. Log in with that password you set earlier, and we're in. Now, what's so cool about this is most of the config that we have demonstrated can be done here in the GUI. So again, if you feel more comfortable doing that, go for it. Let's get back on task here. So first we're going to go to, in the menu up here, network, and then to wireless. Click on wireless. We can see right here we have our wireless radio interface that we just brought up. And then here's the SSID that's being broadcasted. We're going to change that up a bit. So first, I want you to go over here and click on scan. This is so cool. Watch this. Click on scan, and it's going to find all the wireless networks in your area. Great for reconnaissance and great for connecting to wireless networks. Oh yeah. Now for me, I'm gonna connect to my home network, which is port key right here. I'm gonna click on join network. You do the same for your network. And by the way, this is what you'll do whenever you go to a new place. If you want to get their internet for your Raspberry Pi, you're just gonna do the simple process. Super easy. Now, two things we're gonna change here. First, we're gonna check this box to replace the wireless configuration with what we're doing here. And then we're gonna put in our wireless password, which you should have a password. If you're open, then you're crazy. So click the box, bam, and then my wireless password, which I don't remember, I gotta go find it. It's super complicated. Paste that sucker in there, and just notice this, you don't have to change it. It's being assigned to your WAN firewall zone, because it's gonna be a WAN interface, an interface that connects to the internet and gives you internet. So now, we're golden. Just click on submit, and then scroll down just a bit and click on save. And just to make sure things happen, click on save and apply down there. It won't take 88 seconds. It'll be done in like 3 seconds. There we go. Oh yeah. So what we're seeing right here is bam. Our interface is now connected to port key. It's a client now. We're seeing all the stuff about its configuration or its connection. And real quick, if we go up here to status and click on overview to get back to that page where it shows us all the stuff, I scroll down just a bit. Heck yes, I can see what IP address I pulled from my wireless network here. So when you connect to any kind of public Wi-Fi or some Airbnb or hotel, this will be what it connects to and what it pulls right there. So now we should have internet. You want to check it out? Let's try it. Let's get back to command line. I know you missed it. First, can I ping things? I'm not sure if it has ping. Let me try to ping google.com. Yahtzee. We got internet. Yes. Okay. So now, remember, our goal was to get this guy set up. Right now, if I plug him in, the Raspberry Pi will be like, okay, who's this guy? We have to download some drivers so we can recognize this thing. First, we're going to type in one command, OPKG space update. It's going to update its list of packages. Here we go, hit enter. Oh, we got a little failure. I'm gonna try it again. Come on, buddy. Okay, don't be stubborn. It should work. We'll try it one more time. Not liking it. You know what? I'm just gonna do a reboot to see if that fixes it, because that's the best thing you can do in IT. Okay, let's try it one more time. OPKG update. You better work this time, sucker. Yeah, there we go. That's much better. See, a reboot fixes everything, guys. And now I'm gonna celebrate with that little coffee break. Ain't went too fast. Okay, here we go. Now we're gonna install a bunch of packages all at once for this guy. Again, commands will be below. It's gonna copy and paste. We're installing a lot. And within all this mess should be drivers for most of the Wi-Fi USB adapters you have. Anyways, hit enter. It's gonna do its thing. Now we're gonna have a little coffee break again. We've had a lot of coffee today, haven't we? And we're done. Okay, cool. So now we can plug in our USB adapter. Real quick, I'm gonna try something. Type in ls USB. Notice what you have. It's listing your USB interface is what you have plugged in. Notice what you have here right now. Let's plug in our new guy. There you go, buddy. Do ls USB once more. There he is. RA-Link 802.11 in WLAN. Now to bring this guy up, to make him alive, I want to type in one command. And if this command works for you, you know your driver has been accepted. It's good. Here we go. The command will be ifconfig WLAN 1 up. Here we go. Oh yeah. So if I type in ifconfig, listing my interfaces, there they all are. They're so pretty. Here's my internal wireless and my Wi-Fi adapter. Perfect. So now here's the state of things right now. WLAN 0 is doing its thing. It's connecting us to public Wi-Fi or whatever Wi-Fi it's supposed to. Right now it's going to be the Wi-Fi in your house, and it's supplying you delicious internet. WLAN 1, he's doing nothing right now. We got to configure him. What we're going to make him do is become the wireless access point for us to connect to and have internet. Now, after we do this, that's a working router, son. It's going to be ready. You ready? Here we go. We're going to stay in command line land because I'm comfortable here. I love it, and you should too. It's really fun. First, we're going to edit our wireless configuration file. So we'll do nano this time. Nano, the text editor. It's so much easier. Nano /etc/config/wireless. Boom. If we use a directional pad and scroll down just a bit, we You see that first of all, our new USB wireless interface already has some config in here. There he is right there, radio 1, that's his device config. And then there's his wireless interface config, which is actually broadcasting OpenWRT right now. If I check my phone again, that's gonna be him. Actually, no, he's not there. Can you guess why he's not there right now? Because he's disabled. We're gonna change that, aren't we? So let's make a few changes here. First, we need to obviously enable him. Now, the cool thing about Nano is you don't have to do any kind of keystrokes, just start typing away. Change that 1 to a 0, saying no, he's not disabled. Now let's configure his wireless interface. Just a couple things here. First, we'll change his SSID to something that you want. For me, I want to change it to network chuck _trap. Beautiful. I'll change the encryption to PSK2. And just below that, option key, and we'll put in our wireless key that we want to use when we connect to this Wi-Fi. I'm going to put in vacation. I'm going to end up changing that, but that's what I'll put for now. Now that should be it. I'm going to hit, now Nano's different, hit Control X, Y, and enter, and we're saved. We're good. And then just as before, to commit our configuration, we'll do UCI, commit wireless, and then type in Wi-Fi. Boom, we're solid. Now, we can actually connect to our Raspberry Pi's network, and we'll have internet. Let's try it out. Okay, let's see, connect network, chuck travel, put my vacation password in, yeah. Join it, looks good so far. Let's see if I got an IP address. Not yet. Okay, got one. That's on the 1071.70 blah, 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 subnet. Now let's see if I can get something. Let's go to networkchuck.com. Boom. Yes, it works. Okay, cool. So right now you have a working travel router. Like you go to your Airbnb, you go to your whatever it is, public Wi-Fi, Starbucks, you connect it to the wireless by going through the GUI like we just did, and you're good. Like that's awesome, right? But we still have an issue, right? We're not secure, we're not protected, we're not going over VPN. Our network traffic is not encrypted. That's not good. So now for the next part of our config, we're going to set it up to where all of our traffic over this bad boy will go over NordVPN. So no matter where you go, your traffic's hidden and you're secure. So let's try it out. Now keep in mind, while some of these steps are very specific to NordVPN, they should be pretty much the same for most VPN providers. I'm just showing one that I use all the time. So here we go, let's go. And then it should go without saying that you gotta be a paying subscriber to NordVPN, which you should, it's good. Anyway, here we go. First, we need to get our client profile set up. So I got a link below. This will take you to a page where NordVPN will recommend a server for you. And I like that one. If you don't, you can always select your country of preference, but I'm good. I'm gonna click on show available protocols right there. Let me zoom in a bit on that. There we go. So click on that. And then for our example, we're gonna download the OpenVPN UDP config. Download. Got it. Now our task is to upload this file, the one that we just downloaded right here. We're going to upload that sucker to our Raspberry Pi router. And we're going to use secure copy or SCP. So fire up another, so like currently right now we have a command prompt and we're inside of our Raspberry Pi router. We're going to pull up another command prompt or another terminal. This should be the same on all platforms, by the way. Should be. Simple command. First, I'm going to CD into my downloads folder because I know that's where my file is. And then I'll simply type in SCP space. I'll specify my file name, which let me go find it real quick. Kind of a long one. There it was. Space, and then the server or the Raspberry Pi router we're going to upload it to. This will be root at 10.71.71.1, and then we'll tell it where to put this file. So : / we're going to put this in etc etc /open VPN. And then we'll actually have to name the file. So we'll do / and we're actually going to name it this: client.conf for a config. And that's it. It should prompt you for a login. Let's try it out. Yep. Let's get the login for your Raspberry Pi. Boom, uploaded. Let's go make sure it actually did it. So let me pull it up real quick. Pull up my other command prompt. I'll CD to / etc /openVPN. LS that. There she is, client.conf. All we need right there. Okay, so now that we have our NordVPN file configuration uploaded, we can keep configuring our stuff here. Now, don't get scared. This is the notepad with all the commands we're going to enter right now. Don't worry, it's not too crazy. We'll walk through it all together. I'll hold your hand. Let's go. First, we're going to make sure we have our packages installed. Let's grab those first few commands, paste them in there, and we are solid. Now we're going to set some parameters. Let's do that real quick. So here we're going to do our OpenVPN directory. It's telling it where it's going to be. We'll copy that. Paste that sucker in there. We're going to label what the connection will be called. It's going to be called client. Bam. Copy and paste that. Now we're setting the variables for username and password. This will be your NordVPN username and password. So put that in right here, between quotes. So mine is going to be here. It's going to be your email address that you use for your account. And then OVPN pass. And between quotes, I always want to say parentheses, it's going to be your NordVPN password. Just paste that sucker in there, between quotes, and enter. The next script is just going to create a nice little file with those two pieces of data inside of it. Paste that, bam. And then finally, the next section of script will actually create your VPN configuration. Let's copy that just as it is. Some fancy Linux bash scripting. Boom. It did it. Now we're almost there. We're almost done. I know it feels like a lot. This next thing will actually make it to where we can manage this VPN in the web GUI, which we'll take a look at here in a moment. So copy that, go in here, paste it, hit enter. Cool. And then finally, our firewall configuration. We're just going to copy and paste it just as it is. This will allow some things for our VPN to work. And you know what? That's it. That's good. Let's go take a look at the GUI and make sure everything looks solid. We're going to mosey on over to VPN and open VPN here in the menu. And here we go. Here it is. Client, and yes, it's connected. Now we got to test this. Let me pull up my phone. Where'd my phone go? There it is. And actually, first, I want to do this. I'm going to check it or uncheck it, save and apply. This is going to stop my VPN connection so I can actually test and see if I'm on it. Okay, so just verifying here, I am connected to networkchuck_travel. Got my IP address there. I even have my AT&T turned off. All right, here we go. Let's do, what's my IP address? Bam. I'm not going to show it to you, but it begins with 107. The NordVPN one should be different. So let's go ahead and go in here in the GUI. Click that checkbox to enable that and click on Save and Apply. Cool. It's connected. Let's refresh this page and see what happens. Yes, 185. That is a NordVPN IP, which means all my traffic is going over NordVPN through this Raspberry Pi router. Are you freaking kidding me? That's amazing. Yes. Now, I lied. There's one more thing I want us to do. Looking back here at my config, there's a hot plug we want to add to this. Basically, this will make it to where if the WAN interface is disconnected, it will restart our VPN service to make sure it does stay up, which, for a travel router, that's what you want. So I'm going to paste that config in there. Boom. And just like that, my Raspberry Pi here is a router. Not just that, a pretty stinking secure one. It's got me connected to NordVPN, so wherever I go, hook it up, my family's protected. Now, OpenWRT, this thing is a beast. There's so much to it. I spent a good while kind of playing around with it, making sure I was comfortable with it. My goodness, it's powerful. It's open source, Linux, it's the best. And by the way, people often do use the Raspberry Pi as their main router in their house. You can replace your main router with this sucker. Now, it won't be as fast as other fun routers like getting a pfSense router with a beefy set of hardware, but it still does the job. And for me, traveling, it's perfect. I'm going to keep it in the car. It'll give me connection to my NAS, my Raspberry Pi NAS that I have, and we're going to watch Plex movies off of it. And of course, wherever we go, safety. Anyways, guys, that's all I have today. Let me know what you think of the video in the comments.
So, so that's it. This is all you need to know about IoT hacking and other things. So if you want to configure the Raspberry Pi to make your home automated, then you can use this kind of things. Okay. So that's it. So we already almost covered all the modules which are available in cybersecurity. I think these are all the topics. We covered maximum topics as we can. So, ma'am, can we wind up the session? Hello, ma'am, can we wind up the session?
Yes, sir. Good evening, all. We thank you all for participating in the 5 days FTP program, and thank you, Mr. Gopinath, for sharing your expertise in these 5 days. And it was very useful for us, and we learned many concepts, and we had a good hands-on session, practical session. So throughout 5 days, almost all sessions were hands-on, and it was a happy learning for us. And you gave us a maximum input. So that will be
Thank you.
useful for our career. Thank you.
Thank
Thank
you.
you,
Thank you so much.
participants. And you can fill your feedback form. So those who have missed out the feedback form in the previous days also you can fill the feedback form. It is open, and thank you all for your wonderful contribution and participation in the event. Thank you all.
So, thank you all.